Today on Capechi's Corner, we're going to look at some basic terms dealing with circles.
In this first lesson on circles, there's a lot of vocabulary, so feel free as you work throughout the chapter to go back to this and use it as a reference. So when we're talking about a circle, the definition of a circle is that it is a set of points in a plane that are a given distance from a given point, and that point's in the center. So every point on the circle, if we look at our diagram, is equal distance from the center of the circle. Now a radius, as we know, it comes from the distance from the center point to any given point on the circle. So we have two examples here. Segment OD is a radius, and so is segment OE. Now we're talking about a chord now. The chord AB is a segment whose endpoints lie on the circle. Now that chord doesn't necessarily have to go through the center. It just has to have endpoints that lie on the circle. A diameter is a chord that contains the center of the circle. So that is a chord that goes through the center. And in this instance, we have segment DE is a diameter. Now when we're talking about a secant, that's a line that touches the circle in exactly 2 points, and it contains the chord. So the secant here, actually, if I stop at the end of the circles, that creates a chord. But if I continue on through and put arrows on the end to make it a line, that is called a secant. Now the last vocabulary word on this basic diagram is a tangent. A tangent is a line that touches the circle in exactly 1 point. So it doesn't go through it, it just touches it on the outside. And it does have a point of tangency, which in this case is point C. That's the point where it touches the circle. Let's take another look at a basic diagram of a circle. So we have a few things going on here. A segment, remember, has endpoints, so it's something I can measure. So for instance, the radius can be measured. That's a segment. So in this case, the radius is AB, and we also have a radius of AC. A chord is also something that we can measure. So here we have chord EF, and I have to make sure I know that that is going to be segment, so I'm stopping right on the circle so that I can measure it. Another thing we can use as a segment is the diameter. Now we talked about earlier that a diameter is really a chord that goes through the center, and so that diameter in this diagram is segment BC. So everything we've talked about here, the radius, a chord, and a diameter, they are segments, and then they can be measured. Now when we're looking at a line, we have line EF, which is a secant. A secant is a line EF. We also have a tangent. A tangent is a line that will extend in either direction. In this case, it's line L. We have a few other vocabulary words in our first lesson here on circles. So the next one is congruent circles. Congruent circles are circles that have the same radius length. So if we look at our diagram here, we have circle A and circle B, and we know that they're congruent because the radius is marked in each circle as being 3, so we know the value is the same, so therefore we know that the circles are congruent. Now if you think about that, when we did congruent triangles, we knew that those lengths had the same measurement and angles had the same measurement, so this word congruent is used in somewhat the same fashion. When we're talking about concentric circles, we're talking about 2 or more circles that have the same center. So here we have a circle within a circle, and it almost looks like a target or a bullseye. So that's when we know we have concentric circles. Now when we have a polygon of any type inside a circle, there's 2 ways we can talk about this. We can say the polygon is inscribed in the circle, and we know that's occurring when all the vertices lie on the circle. So all the vertices have to be touching the circle. If they're not touching the circle, then we can't say that it's inscribed. The second way to describe the same diagram is that a circle is circumscribed about the polygon. And I like to say about, almost sounds like the word around. So we know that circumscribed is about the polygon. The circle's on the outside and the polygon is on the inside.